Good day! I'm Syazwina A. Idris.
I am Maria Jamie Loren Pono
And I am Joanne, Pauline, and Baao
from the Pamantasan ng Lungsod ng Maynila,
College of Architecture and Urban Planning,
BS Architecture, 4th year, Block 1,
and we are here to discuss
a topic from cross analysis.
which is method of joints.
So we are here to discuss method of joints. The problem given is to compute the force in all members of the truss shown in the figure. So as you can see, here is the figure given. There are vertical forces acting upon the figure, which is 50 kilonewton and 30 kilonewton. So the first thing to get is the moment. Since the figure shown is in static, we can conclude that the summation of moment in force A is equal to 0.
So to get the reaction force, we would multiply the total distance, which is 11, and multiply it to the reaction force and equate it to 4, which is the distance from A to C.
And multiply it by 50 kilonewton plus 8, which is the distance from A to E, and multiply it by 30 kilonewton. So from there, we can
Obtain the answer 40 kilonewton. So 40 kilonewton is the reaction force. After getting the reaction force, we would proceed to joint A.
So here is the free body diagram of joint A. In this free body diagram, we can see the distances, which is the y component, which is 5, and 4, which is the x component. From here, we can obtain the hypotenuse, which is square root of 41, by using Pythagorean theorem. So the summation of vertical forces in joint A is equal to 0. To get the value of the force acting on AB, we would multiply it to 5 over square root of 41 and equate it to RA, which is the force acting on A. Since we already obtained the value of the force acting on A in our previous solution, we could substitute the value 40 kilonewton into this equation. So after obtaining this equation, we would get the value of the force acting on AB. So the force acting on AB is equal to 51.22 kilonewton, which is compression. The summation of horizontal forces in joint A is equal to 0. To get the value of the force acting on AC, we would multiply 4 over square root of 41 times the force acting on AB. Since we obtained the value of the force acting on AB in our previous solution, which is 51.22 kilonewton, we can substitute it to our present equation. So our final equation would be 4 over square root of 41 multiplied by 51.22. From this, we can obtain the answer 32 kilonewton tension.
Now let us proceed to joint B. Here is the free body diagram on joint B. As we could see, there are 4 forces acting on it, namely FBC, FAB, 50 kilonewtons, and FBD. Let us now solve for FBD. We can get FBD through the summation of horizontal forces. Through the given distances, we can compute for the hypotenuse through the Pythagorean theorem. We will then get the equation 4 over square root of 17 FBD is equal to 4 over square root of 41 FAB. Since we have a value of FAB, we can then substitute it to the equation, and then we will get the next equation, which is 4 over square root of 17 FBD equal to 4 over square root of 41 times the value 51.22. We will then get the FBD, which is equal to 32.98 kilonewtons compression. Next, let us compute for FBC. We can get the value of FBC through the summation of the vertical forces, equal to 0. With the given values, we can obtain the equation FBC plus 5 over square root of 41 FAB plus 1 over square root of 17 FBD is equal to 50. The next, since we already obtained the value of FBD from our previous equation, we can now substitute it to this equation. We will now obtain the equation FBC plus 5 over square root of 41 times the quantity 51.22 plus 1 over square root of 17 times the quantity 32.98 is equal to 50. The result of our FBC will be 2 kilonewtons compression.
As we can see in this free body diagram, there are 4 forces acting on joint C, namely FAC, FBC, FCD, and FCE. To compute for FCD, there are given distances that will be used to get the hypotenuse using Pythagorean theorem. The summation of vertical forces at joint C is equal to 0. So 1 over square root of 2 times FCD equals FBC. Since FBC is already obtained in the previous equations, we will just substitute its value to our equation, which is 1 over square root of 2 times FCD equals 2. So we will have the answer of FCD 2.83 kilonewtons tension. The summation of forces on the horizontal is equal to 0. FCE plus 1 over square root of 2 times FCD is equal to FAC. Since we already have a value for FCD, which is 2.83, we will just substitute it to our new equation, which is FCE plus 1 over square root of 2 times 2.83 equals 32. FCE is now 30 kilonewton tension.
So let's proceed to joint E. The summation of horizontal forces is equal to 0. The force acting on EF and CE is equal. Why? Because the summation of horizontal forces is equal to 0. In this free body diagram, the horizontal forces present are the force acting on CE and EF. So if we subtract 30 kilonewton, which is the force acting on CE, to the force acting on EF, it should be equal to 0. If we transpose the force acting on EF, it would result to 30 kilonewtons. So, if we go back on joint E, we can conclude that the force acting on EF is equal to 30 kilonewtons, which is tension. The summation of vertical forces in joint E is equal to 0. So, from this body diagram, we can say that the force acting on D is equal to 0.
Let us now proceed to joint D. Here is the free body diagram for joint D. As you can see, there are 5 forces acting on it, namely FDE, which is equal to 0, FCD, FBD, 30 kilonewtons, and FDF, which is the value that we would solve for. To obtain the value of FDF, we can use the summation of horizontal forces. From the given distances, we can obtain this equation. 3 over 5 FDF plus 1 over square root of 2 FCD is equal to 4 over square root of 17 FBD. From that equation, since we have the values of FCD and FBD, we can substitute it to the next equation. Doing so would get us the equation 3 over 5 FDF plus 1 over square root of 2 times the quantity 2.83 is equal to 4 over square root of 17 times the quantity of 32.98. Upon working on that equation, we would obtain the value of FDF, which is 50 kilonewtons compression.
So to check if the body is in static, the total of all the forces should be equal to the force acting upon F. So, summation of vertical force is equal to 0. 4/5 FDF is equal to 1/17 FBD plus 1/square root of 2 FCD plus 30. So, since we got all these forces a while ago, FDF is equal to 50, FBD is equal to 32.98, and FCD is equal to 2.83. The total amount of force is 40 equals 40.
Thank you for watching.
They can imitate you, but they can't duplicate.